Okay, today we're going to practice doing the product rule, but in a much quicker way. If we have the question on the board, we're used to perhaps doing something like the following. We write our pieces. We differentiate each piece. That was a 3, so that's why I'm just checking my work. 3 cos 3x. And then what's our rule? Well, our rule is that we sort of crisscross them, don't we? So we have u dv plus v du. Now, because we crisscross them and we sort of keep one, differentiate, and over here we sort of keep this one and differentiate this. Well, because it's multiplying and the order is not too important, and then also because we're adding and that order isn't too important, well, because the product rule is so common, we may wish to speed this up and do this keep, differentiate, differentiate, keep, or some kind of version of that. So let's try that now. So I'm going to keep it. I'm going to differentiate this bit, which is 3 cos 3x. And then I'm going to add. So what did I do just then? Well, I kept and I differentiated. So now let's differentiate and let's keep. So if we differentiate, we get 2x, and if we keep it, we get that result there. Okay, so a very, very quick way to do it. That would be g-x. So when you have the product rule, keep, differentiate, differentiate, keep. Find the exact value when we have pi over 6. Okay, well, that's not a big deal. What would we do to kind of finish with that one? Well, we get pi squared over 36. That one there is equivalent to sort of 30 degrees. So, well, it will be 90. So that's a 0. So that's all going to disappear. So I'll put times 0. All right, but that will all disappear. 3x there then would be 3 pi over 6 on the outside. And sine of 90 is going to be 1. So this should end up being, for example, pi over 2 as a final answer. Let's try this trick another time. So we're going to keep, differentiate, differentiate, keep. Keep is this, differentiate is this. Okay, that was keep, differentiate. Let's now add and let's do differentiate, keep. If we differentiated, we would get 2 cos 2x, and if we kept it, we would get cos x. Let's do the cleaning up. So this is going to be, well, minus sine x sine 2x. Maybe we might be asked to do something else with that in a question. And then over here, this is going to be, well, just 2 cos x cos 2x. Okay, so maybe I might be given some more instruction to handle these sorts of parts, but to differentiate it, you can see, is really quite quick. Let's do one more. So we're going to keep, differentiate, differentiate, keep. If I keep 3x minus 1, it looks like that. If I differentiate, I'm going to get 2e to the 2x. The next part is going to be differentiate. Well, differentiate is simply a 3. And keep is just like that. Where may we go next with the question? Well, maybe we might do some sort of factorizing or something. So it would be quite common to have a step where perhaps you would take e out because it was in both parts, and that would leave you with what? That would leave you with 6x minus 2 plus 3. So you would have e to the 2x being multiplied by 6x plus 1. Okay, find the exact gradient at 1. So, yeah, we could do that, couldn't we? That would just be e squared times by, well, I suppose times by 7. Okay, and it asked for the exact answer. So that would be the exact answer. So keep, differentiate, differentiate, keep.